All right, we're still in 8-2. I just kind of want to continue our notes. This time with law of cosines. If you'd like to see where the law of cosines comes from, we can do that in class. I'll show you how to derive it. It's a little more complicated than law of sines, but that's okay. So in this situation, let's like what is t? We want to find that. But let's see. I can't use SOHCAHTOA or Pythagorean theorem because it's not a right triangle. Law of sines, I don't have an angle and a matching side because I don't know any of the other angles, so I can't use law of sines. So I have to go to the law of cosines. And remember that you're talking about like an a squared equals b squared plus c squared minus 2bc cosine of a. That's kind of your general formula for how this works. But notice we're not using a, b, and c. So what you basically just have to realize is like, oh, the side here and the angle here, these have to match, and b and c are the other two sides. Okay, so what I did here is set up like this. T squared, because I know t goes with this angle, so t squared equals the other sides, 9 squared plus 17 squared minus 2 times 9 times 17, these used again, cosine of 65, the angle that matches up with this side. The good news with this, I know that looks like a big long formula and kind of intimidating. At the same time, this is actually really easy compared to law of sines. You can actually type all of this into your calculator, and you'll just get t squared equals roughly 240.678, etc. And don't forget, the last thing is we're going to take the square root of both sides. So actually you just get 15.5 and we're done. All right. Let's try that again. So we got this triangle again. I just drew a visual aid. Somehow I missed L. Not sure where L went to. There you go. Something got covered up there or deleted. And just make sure we got everything. So across from J should be 15, across from K is 13, and across from L is 12. So notice here is like when I find angle J, I don't know even any angles. So like I can't use SOHCAHTOA, can't use Pythagorean theorem. Not that I would need it here anyways. I know all the sides. So it's like, whoa, what do I do here? So let's set it up like this. We want to find this angle so that matches with this side. So 15 squared equals the other two sides squared, 13 squared plus 12 squared, minus 2 times 13 and 12 used again, cosine of j. So I can also use law of cosines to find a missing angle. Okay, like I said, side, side, side situation. Now, be careful here. Don't get too greedy and put all this in the calculator. I can do 13 squared plus 12 squared. Those can be combined and they become 313. 15 squared is just 225. 2 times 13 times 12 gives you 312. You cannot combine the 313 and the 312. Remember, this 312 is attached to the cosine. It's like saying 313 minus 312x. You can't combine these together. Actually, what you're going to do is subtract the 313. So I'm going to subtract 313 on both sides. Okay, and you can see what you get down below there. Okay, so be careful there. Don't get greedy and start putting it on the calculator. Don't start combining stuff that can't be combined. So this just comes down. The only way to get rid of the negative 312 is to divide. So you're going to divide both sides, which makes this a positive 0.28205, etc. And this time around, you're going to use an inverse cosine. So we'll do the inverse cosine and get angle J. In this case, kind of like a weird typo there. Oh, that's supposed to be a 0 there. Sorry, guys. You can kind of just ignore that. Just ignore that there. Just type in this here, inverse cosine of that, and then you get J is about 73.6 degrees. Okay, so also cosines can also be used to find missing angles. There is no ambiguous case here, like we talked about with law of sines. What you see is what you get, which is another reason I like law of cosines. Like I said, it looks more intimidating, but it's kind of nice. This example B is very similar to the one we just did up above, so feel free to pause and try it out. We can talk about it in class if you can't figure it out, but the answer should be 11.5 for side C. Wouldn't be complete if we didn't try a little word problem here, so let's finish up with this. So you got the situation, feel free to pause, figure it out. Ultimately, we want to find this angle up here. The problem here is I don't know the angle, so I have the matching side, but that's not good enough. I have this angle, but I don't have this side. I have this side, I don't have this angle. So you can't always directly go and get what you need. So in this situation, I might find this height h of the flagpole. So h squared equals 1.2 squared plus 5.3 squared minus 2, 1.2, 5.3, cosine of 68. So use my law of cosines to find this missing side, since I know it goes with this angle. Once I have that information, I can then go and use other things to find the actual angle that they're looking for. They're looking for this angle up here. I think I called it like angle X. Okay. So I'm just going to, this time I can combine all this together, get a number, and just go ahead and square root that, and you get roughly 4.98. I might use a few more decimal places since I'm going to use this answer to find other things. I mean, there was no other way to find what I need. I had to use this rounded answer. Otherwise, I'd try to avoid that. But now I can use the law of sines. So sine of x over 1.2 equals sine of 68 over 4.98, that value I found. And now I can do like we did before and find my missing information. Cross multiply here. Eventually you're going to have to divide by the 4.98. And you'll also have to do an inverse, and you get an angle of 13 degrees. You could try out that ambiguous case. Is there a second triangle? But that angle would be really huge. You're talking like 167 degrees. So that would not work. If that was 167 plus 68, that would not work. And that's all there is to it. Just a little concept summary. Bring some questions to class, and we'll go over them.